Hey everyone, I'm Vaibhav Khandelwal and I welcome you all to Simplilearn's YouTube channel. In this session, we will discuss Radix sort algorithm. We shall begin our session by introducing Radix sort. Then, we will discuss Radix sort algorithm. After that, we will implement Radix sort algorithm in the code editor. Finally, we will sum up what we have learned from this session. But before we begin, make sure you have subscribed to our YouTube channel and clicked on the bell icon below so you never miss an update from Simplilearn's YouTube channel. So without any further ado, let's get started with an introduction to Radix sort. Radix sort is a non-comparative sorting algorithm. It avoids comparison by creating and distributing elements into buckets according to their radix. And for elements with more than one significant digit, this bucketing process is repeated for each digit while preserving the ordering of the prior step until all digits have been considered. Now let's discuss Radix sort algorithm. Let's say we have an array. First, we will find the largest element in the array to decide maximum number of significant digits we will need to compare to sort this array. We will go through each significant place and sort the array one by one. First, we will sort the array according to the units place. Then, we will sort according to the tens place. And then, we will sort according to hundreds place and so on till the array is sorted. We have now introduced the Radix sort and its algorithm. Now, let's implement this algorithm in the code editor. We will start with an utility function to get maximum value in this array. So int get max with an argument as array arr, comma size n. We will declare variable int mx is equals to arr at 0, and we will write a for loop where int I is equals to 1 to I less than n at I plus plus if arr at I is greater than mx, then mx will be equals to arr at I, and then we will return the value of mx. Now we will write a function to do counting sort of array arr according to the digits represented by exponent. So void count sort at int arr, comma int n, comma int exp. We will declare an integer array output int I, comma a count array of size 10 where all elements are 0. Now we will store the count of all the elements of the array arr. So for loop I is equals to 0 from I less than n to I plus plus count arr at I divided by exp modulus of 10 plus plus. Now we will change count I so that count I now contain actual position of this digit in output. So for I is equals to 1, I less than 10, I plus plus, count I plus equals to count I minus 1. Now we will build the output array. So for loop at I is equals to n minus 1 to I greater than equals to 0, and I minus minus output count ARR at I divided by exp modulus 10 minus 1 is equals to ARR at I. And now count ARR at I divided by exp modular 10 minus minus. Now we will copy the output array of ARR so that ARR now contains sorted numbers according to the current digit. So for I is equals to 0, I less than n, I plus plus, ARR at I is equals to output at I. Now let's write the main function that will sort the ARR using Radix sort. So void Radix sort int ARR comma int n. Int m is equals to get max ARR comma n. Now we will do the counting sort for every digit. Note that instead of passing digit number, exp is passed. Exp is basically 10 raised to the power I, where I is current digit number. So for int exp is equals to 1, and m divided by exp is greater than 0, while exp is multiplied equals to 10, we will do count sort on ARR of size n with exp. Now let's write a function to print this array. So void print array int ARR comma int n for int I is equals to 0, I less than n, I plus plus, say out array at I. Now let's write the main function. We will declare int ARR bracket with values 170, 45, 75, 90, 802, 24, 2, 66. Now we will find out the size of this array ARR. N is equals to size of ARR divided by size of ARR first element. Now we will call the Radix sort function. And we will print this array. Now let's try and execute this. As you can see, we have successfully sorted this array using Radix sort. Let's get back to our slides. At last, let's sum up what we have learned from this session. First up, Radix sort can be used on lexicographically sortable data. Next up, Radix sort utilizes the count sort algorithm. Next, Radix sort is done by sorting elements using significant digits. Finally, Radix sort consumes more memory space than quicksort. And this was all for today's session. Hope you guys found it informative and helpful. If you liked this session, then like, share and subscribe. If you have any questions, then you can drop them in the comment section below. Thanks for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.